Hi, welcome once again to Lane's ED Enhancement channel. Today we will continue using the storage factor formula along with payload to solve some simple calculations. This is Simple Calculations Part 2. The objectives are calculating payload and volume usage, illustrating how storage factors are used while loading containers. Finally, determining when it's best to use a 20-foot or a 40-foot container. Now let us look at small storage factor or a heavy cargo. Remember in an earlier video, we said that the heavier a commodity is, the less space it will occupy. Therefore, the smaller its storage factor will be. Also, containers are marked with their maximum payload, gross weight, tear weight, also their inside measurements. So the following illustrate how storage factors are used while we are loading a container. Let us look at this example. A cargo planner decides that a heavy cargo will be tightly packed in a 20-foot container with an internal volume of 31.14 cubic meters, weighing 2.5 tons, and with a maximum gross weight of 24 tons. The cargo has a metric storage factor of 1.2. We are asked to calculate the maximum payload of the given container and also to work out the percentage of volume or space which will be used up in this particular container. Now let us look at the solution. Since payload is equal to the gross weight minus the tear weight, and our gross weight given is 24 tons, we are going to take away the tear weight of 2.5 tons, gives us the maximum payload, which is 21.5. Remember, payload is the maximum weight that a container can carry safely. Safely, most important. Now, the payload to fill such a container or a space of 31.14 cubic meters, we would divide by the storage factor of 1.2. This will give us the weight. The weight we get is 25.95. Now, with a maximum payload of 21.5, we see where this container would have been overloaded by 4.5 if we should put all this cargo in the space provided. Now let us look at the percentage of the volume or space that would have been used. The maximum payload is 21.5, which is what we can actually put inside of the container. And so we are going to divide that by the weight that can actually go into the space, which is 25.95, multiply by 100 to give us the percentage of 83%. Now, let us look at the same 1.2 storage factor cargo being loaded into a 40-foot container. Again, the cargo planner decides that a heavy cargo will be tightly packed into a 40-foot container with an internal volume of 66.7 cubic meters, weighing 4 tons, and with maximum gross weight 30 tons. The cargo, as we said, is the same metric storage factor of 1.2. Again, we're going to calculate the maximum payload of this container and the percentage of the volume which will be used up. Now let us look at the solution. Again, we know that payload is the gross weight minus the tear weight. This time for the 40 foot, it's 30 tons minus 4 tons gives us 26 tons. So the maximum payload of this 40 foot container is 26 tons. Now let us look at the payload to fill this 40 foot container. Here the space is 66.7 cubic meters and we divide it by 1.2 cubic meters per ton, resulting in 55.6 tons. Wow. So this container with a maximum payload of 26 tons, we realize would be overloaded by 30 tons. Let us look at the percentage of the volume used. We have the payload, maximum payload of 26 tons, and we're going to divide by the actual weight that can go into such a space and multiply by 100 to give us the percentage. The result is 47%. Which container would you use to carry this 1.2 stowage factor cargo? Let us look at the options. 20-foot container carrying the maximum payload of 21.5 tons with the volume usage of 83%, as against 40-foot container carrying the maximum payload of 26 tons with a volume usage of 47%. It can readily be seen that there is a better usage of space with the 20-foot. So these containers are usually used in the shipping industry to carry the heavier cargo. Now let us look at some other examples, because we would see using the 40-foot container here would be underutilization of the space. Now, let us look at the payload calculation for a large stowage factor, which is a light cargo. In an earlier video, we had discussed that the lighter a commodity, the more space it is going to occupy, and therefore you will have a higher stowage factor because the volume is greater. Now, we are going to be using the same 20-foot container, and the cargo planner again decides to put some cargo inside of this container. This time it's a cargo with a metric stowage factor of 2.9. This time we're going to calculate the payload, and we are also going to see if this container would be filled to its max when we actually put those cargo in it. Now let us look at the solution. Again, the maximum payload which has already been established for this container is 21.5 tons. The weight is 31.14 cubic meters, and we're going to divide by 2.9 cubic meters per ton, which is the stowage factor for this particular cargo. This time we get 10.7 tons. So the container can be filled without exceeding the payload. As a matter of fact, only approximately 50% of the payload was impacted. So we see, based on the payload being 21.5, and we can actually it takes 10.7 ton of this cargo to full the space. We can even use two 20-foot containers and we still would not have reached the maximum payload because 2 times 10.7 give us 21.4 tons. Now, let us look at a 40-foot container with this same 2.9 metric storage factor cargo. We are going to again look at the max payload, and then we are going to see if this container can be filled with this particular cargo. Solution: the maximum payload has already been established. Yes, 26 tons. The weight can be calculated by using the volume, which is 66.7 cubic meters, this time dividing by this 2.9 cubic meters per ton cargo, resulting 23 tons. So the container can be filled without exceeding the payload capacity. So this resulted in approximately 89% of the maximum payload. So based on this, we can clearly see that one 40-foot container would still hold more than even the two 20-foot containers, because this 140-foot is holding 23 tons as against 21.4. Now let us analyze this scenario. Which container would you use to carry this 2.9 storage factor cargo? You are given the option: 20-foot container with a maximum payload of 21.5 tons, and it was filled with approximately 50%, 10.7 tons. Or a 40-foot container with a maximum payload of 26 tons, filled with approximately 89%, which equates to 23 tons. It is evident in this case that the 40-foot container would be the preferred choice, as one 40-foot container, as I said earlier, would still carry more of this particular cargo than even two 20-foot containers. Now let us analyze the overall use of 20-foot versus 40-foot. Now, from the viewpoint of cargo capacity, it is better to use 20-foot container for heavy cargo, and this includes canned goods and so on. As an example, the 40-foot containers are primarily used to carry the light cargo, electronics, for example. So in the shipping industry, it can be a little bit a touch and go, because the charges for one 40-foot container would be less than for two 20-foot containers when we're looking at the handling costs. So please remember now to like, to share, leave a comment, and as I said, most importantly, subscribe to this channel. I want you to hit that notification bell, and you will be advised when we have more videos uploaded to assist you. When we will next, I'll see you as we'll be looking at more realistic scenarios the next time, things that occur in the actual shipping industry. So see you.